question then becomes, is where can you put these base APPN products who don't support the APPN session service extensions? Where can you locate them physically in the network and still allow your session services extensions functions to work, like closed as pass, for example? So the APPN session services extensions exploitation requirements is this. Clearly the nodes that own the endpoint LUs, in this case end node A and end node B, those nodes, the owning control points of the resources involved, have to be session services extensions capable, or else you're never going to get any of these session services extensions type sessions established. The only other requirement is that the network node server of each of these two endpoint control points also have to support the session services extensions. So one supports the SSE end node function, one supports the SSE end node and network node function, endpoint and intermediate network node function. But these other two network nodes in the middle here could be base APPN products like AS400s configured as network nodes. And we can still use them as part of our APPN transport network, our backbone network if you will, as long as they're not acting as the network node server or the owning control point for any of the LUs involved in one of these SSE type of sessions. All right, so even in this network where you've got two AS400s and the session path from end node A to end node B must traverse at least one of these AS400s, this session path can still support the session services extensions. Okay, so now that we know what the session services extensions are, we'll go into the dependent LU requester, dependent LU server function. I can still remember when VTAM v4r1 shipped, it did not have DLUR, DLUS included in it at all. And the press release says, VTAM ships first APPN release, doesn't support dependent LUs, which couldn't have been further from the truth. It supports dependent LUs exactly the same way that it supported them in a subarea network. You had to have them directly attached to a VTAM boundary function or attached to an NCP boundary function that was owned by a VTAM, basically. So the APPN session services extension support, it allowed you to do the same type of dependent LU support even without DLUR, DLUS. So the idea now is you had a composite network node with some NCPs, maybe some remote NCPs, and you had the devices, dependent LUs hanging off here basically. And if you wanted to start a session to an application that resides on an APPN end node, for example, you could send APPN session service extensions flows between the two owning VTMs. We would route the session path directly up here or directly down to the NCP and then down again. There were some limitations with this. First of all, it still requires this composite network node. A lot of people are trying to migrate off to 3745. The second thing is that because the NCP down here does not play full APPN functionality, remember, it has to work together with VTAM to provide that composite network node appearance. One of the functions the NCP can't do is the RTP endpoint function. It can do A&R routing as an intermediate node on an RTP pipe path, but it can't be the endpoint of an RTP path. And for that reason, if the session takes the direct path from the end node down to the NCP and then out to the device, this link is doing ISR routing, not HPR routing. And most customers would prefer to have HPR routing for their dependent sessions as well as for their independent LU sessions. So the DLUR, DLUS architecture was invented to try to eliminate those two problems. The way DLUR, DLUS works is we need to find a way to activate LUs that are across the network. We used to send our activate LU and activate PU requests along a virtual route with an element address in there that basically identified which LU or PU we were directing the ACPU or the ACLU to. You can't send an activate LU or an activate PU request across an APPN network and expect intermediate network nodes along the path, especially non-SSE capable intermediate network nodes along the path. You can't expect them to forward the ACLU correctly. So we had to find a way to be able to deliver these ACPU and ACLU requests down to the SSCP, or down to the PUs and LUs down below the DLUR. And the way we decided to do that was to establish a set of LU62 sessions between the dependent LU server, the owning VTAM, and the dependent LU requester. Whatever node is basically taking the place of the NCP boundary function. In this case, it could be a Cisco SNOS switch, it could be any of the PCOM products. Those are the kinds of nodes that support the dependent LU requester function. By establishing two LU62 sessions, which we call the CP server manager sessions, we're allowed to send data along those LU62 sessions, and the kinds of data that we send are ACPUs and ACLUs, and we get request ACPUs in, or we get ACLU responses, ACPU responses back. They basically flow over this pair of dependent LU sessions. Because these are our LU62 sessions, and because typically the DLURs are HPR capable, not only are the CP Server Manager sessions capable of performing the HPR function, because this guy down here is RTP capable, But if you start sessions directly from an application host down to the DLUR over a direct link, this guy can play RTP endpoint for those RTP pipes as well. So we've moved the dependent LUs further out in the network. They no longer have to be physically adjacent to a VTAM or an NCP, which was one of our requirements. And now direct sessions from a Plu application host to the DLUR support the HPR function so that you get HPR as well. Right? So you get more intelligent routing, you get session paths that use HPR, and you get much more configuration flexibility by moving to a DLUR DLUS configuration. The next chart here is on dependent LU requester placement. Where would we want to place our dependent LU requester? The only nodes that support DLUS function are VTAM nodes, because we're the only ones that support activating dependent devices. The question that most customers will ask us is, should I make my DLUR some kind of gateway node into my branch office and let these downstream devices look like they're downstream dependent PUs that are attached to the DLUR device? Or do I want to cause my DLUR DLUS sessions to move all the way down to the workstation, have everybody's PC act like a DLUR? All right? And that way, there are a couple of advantages to each of these and a couple of disadvantages. And we really don't have a recommendation on which method customers use. It really depends on what they think are the most important requirements for their DLUR DLUS configuration. For example, in the case where we have a Cisco SNA switch acting as the DLUR, you have much fewer RTP footprints. You do not have CP server manager sessions to every workstation. You only have them to that gateway node, and he fans out all the requests to the workstations below them. So you have much fewer RTP footprints. On the other hand, this is the Cisco SNA switch here, sees every session that comes through here because he's got to convert from HPR to dependent LU. As such, the Cisco SNA switch box needs to maintain session awareness of every session. And because of that, you might find out that this gateway box has to be larger than usual. It has to have a bigger CPU and it has to have more storage. The alternative, as you come over here to this picture, is the gateway boxes now, which could be SNA switch or CSNT or CS Linux. They're only doing A&R traffic. They're intermediate nodes on the RTP pipe path for the DLUR DLUS sessions and also for the LU-LU sessions that come all the way down to these DLUR workstations. So these gateway nodes now no longer need to be as big a box because they're only doing A&R routing and they're not maintaining session awareness. The DLURs probably don't need to be big boxes either because they're not handling a bunch of sessions, they're only handling the sessions for the resources on them, which is typically just a single workstation. And the other advantage of this configuration is that if you're using duplicate ticking or some other type of high availability connectivity, if you happen to lose one of these nodes, your RTP pipe sessions can actually path switch over to another one of the gateway nodes down in this box, which gives you the ability to recover some of those sessions in the event of certain failures. So both of them have their advantages and both of them have their disadvantages. Of course, the disadvantage to this one here is that you've got a lot of these RTP footprints, if you will, a lot of RTP pipes, a lot of DLUR, DLUS sessions, which really does not affect the downstream devices as much, but it may affect the DLUS because he's going to be the other end of all of those sessions and the other end of all of those RTP pipes. So you can decide which one based on the trade-offs, pick the configuration, implement it that way.